Hello world, welcome to Decoded. So today we are looking at a new project that I have created, which I'm really excited about, called Ducklake-SDK. In this video we are going to explore what this project can actually do, and some ways it could be super useful in your own stuff. So to be real, building a data stack from scratch can be a massive headache, and this project is here to alleviate that. In a nutshell, it's a starter kit for building your own personal data lake. It lets you pull data from all over the place, transform it, run automated pipelines, and even whip up some shareable dashboards if you want. So if you're a fan of how insanely fast DuckDB is, you are going to love this one. See, Ducklake is built on that same principle: high speed, low friction, and lightweight, and developer friendly, and just fast. So for a quick heads up, this project is brand new and evolving fast, so things might look a little different by the time you see this, but it's okay. We are going to focus on the core concepts that will stick around. Also, Airflow released a new version last week, including some breaking changes, and this project is designed to be compatible with the new release. So by the end of this video, you will know how to connect your data sources, transform raw data into your clean and queryable tables. So in case your data lake is star schemas, fact tables in that case, and automate the whole process and launch some simple dashboards as well. And the best part of it is it is all done in one code base. I'm not quite a fan of singletons, but this means your entire setup is version controlled, reviewable, and somehow repeatable. So yeah, grab a coffee and let's build our data stack from the ground up. Before we start, let's get a quick mental model about how DuckDB with Ducklake extension work. Think of Ducklake as having two key parts work together: the catalog and the storage. And it kind of is exactly like how Apache Iceberg stores the data. And the catalog is kind of like the citation. It is a small database that keeps track of everything: what tables you have, where the data files are, and which version is the latest, and all the metadata about your actual data. And the storage is the muscle. This is where your actual data files live. All the different versions of the files are physically stored inside your storage. So to make this work, you just need two things: a database for the catalog, something like Postgres in production, or even just SQLite for local testing, and a place to store the files, like S3 bucket, or if you want to just play around, just a folder on your machine will do. Now, the repo I have created here made this pretty simple. I have a directory called infrastructure under the root of the project, and inside it there's a Docker compose that spins up all the helper services that we need using one command. And the stack includes, as I've told you, PG database, pgadmin to explore my PG data, and Minayo. And also, you might know the console comes with the Minayo itself. And what's the secret sauce here? There is a core class that I have created here called Ducklake Manager, and this is the brain of the whole operation. It reads a simple config file, validates your settings, and automatically wires everything together for you, so you do not need to write any tedious glue code. And the config file itself is beautifully simple. You mainly care about two things: the SRC and the destination. The destination defines where your data lake lives, the catalog database and the storage bucket, which I have already talked about. And the SRC is simply where your data is coming from: CSV, another database. And for each type of connections, you can have multiple defined sources. So I have two Postgres under the Postgres connections and one S3 bucket as my data source. This is where my raw data is coming from to be inserted into my Ducklake. And the killer feature here is you can completely change your environment just by tweaking this config file or write a new one. So the bottom line is we are about to spin up a few services. which is I've already pointed my destination to. So let me go ahead and head over to infrastructure and run my services. So seems like our backend services are live, and we have our storage, our storage and our catalog, and these are the Ducklake's foundation, primary foundation actually. So once I point my Ducklake manager to my config file, which I have showed you here, all my data sources light up and become queryable from my DuckDB engine. But the problem is these data sources does not exist just yet. That's because I have created a sources sample directory. This is not a part of the project, and this is just for test purposes, and I'm going to head over to this directory and run my sources sample in order to show you. So there they are. Here I have sample PG, sample PG1, sample PG2, and sample min.io to act as my sources playground. So here under the source that I have, where is my config file? Under the source, each one of my connections gets an alias. That's the alias that I am using to mess around with the specific data source that I'm defining in here. And over here in my command line, I have defined 3 main commands. I'm gonna skip diving into the details for the source code. That's for the next part of this video, where we clone the repo, poke around the source code, and get everything working. But here I got a test command that lets me kick off my Ducklake manager and point it to my config file and just mess around with it. All right, for the source side of my Ducklake setup, I have tossed in some sample data in my playground data sources. So one table in each of the databases I have showed you, and a single Parquet file for the S3 bucket. So if I go ahead and head over to my PG admin, I have already registered these playground sources inside my PG admin. So I believe this one, yeah. And if I head over here, I have 2 sample PGs registered here. They're completely decoupled from each other, but since they're under the same network inside my Docker, I should be able to resolve the hostname for my data samples. So all of them are under the network of LakeNet. So if I look in here, I have tossed in some sample data. The sample PG1, there is a table with all the details on penguin species. So this is what we are looking at here. There it is. And in the second one, they have information about their addresses in Australia. So this is my addresses. I've already took the sample from each one of these tables, and inside my S3 bucket, which is my third source, so I should head over to the console in order to see that, I have created a bucket called data source, and just added a Parquet file including information related to the suburb data of my addresses. So these 3 sources are joinable. The penguins can be joined with the addresses using their ID. So penguin ID should be residence ID inside the sample PG, and each of these suburbs are coupled with the column inside my suburb data. So if I head over here and look at my Ducklake manager, I have initiating it using my, let me just head over to the root of the project. I'm initiating it using my config file, which I am defining here inside my command line. And I should be able to join the data between these 3 sources simply by reading this config file that I have just showed you. And as you might be able to see, the scope for the sample, for the MinIO connection, is the keyword that Ducklake reads in order to recognize which connection to use in order to to read these specific bucket. And for the post response, you should just simply add this before your schema, and Ducklake will know which connection to use in order to read that data. So as you might see here, we have sample PG2 public and addresses should be available for us, and sample PG1 public penguins. And for the S3 data, I'm using the method read packet, and as soon as I am defining my bucket, the Ducklake will recognize which connection to use in order to read that. So if I go ahead and run this, I should be able to join these three sources all together. So here we have some data about penguins that living in Australia houses and the house prices. And so if you're negotiating rent with your penguin landlord, this might come pretty handy. So the real key here is that all these data are tangled together in one query, and this is kind of impressive. But if you go ahead and take a closer look at the project structure, it brings some pretty impressive functionality to the table. We have pages in here, and this is how I'm dynamically importing my files from the pages directory in the runtime. So let me just demonstrate that for you. If I go ahead and run Lake serve, it should be able to serve a simple panel for me. And inside this panel, I have house prices and the residence dashboards. So house prices is directly reading from an outsourced data that my Ducklake should have access to. So this is reading my data source suburb data and simply create dashboards from the raw data. But here I have a query that is reading from a table inside my data lake itself. So I have created this table inside my data lake like this, and this is the query that creates the table. And over here we have a query that reads everything from that table and just creates a dashboard using that table. And if I go ahead and add some, let me just copy and paste this one and call this sample and put it here, in the next refresh my sample should be available within my dashboards, and this directory is actively being scanned each time a change happens inside my data source, which is pretty cool. But this still misses a lot of things. So while this real-time updating is pretty cool, the data source is still reactive. You have to manually change your data in case you want to read from your Ducklake and manipulate its power. In case your data source is one or many of these sources that you have defined in your config file, then you will be okay, because each time you refresh, you refetch the data from all these sources and get the fresh data each time. But what good is Ducklake if you do not want to store your data inside it? I mean, the good old DuckDB could have done the same before, because it was a query engine just like Trino, but for big data purposes. And so to make this, to take it to the next level, we need to make it somehow proactive. We need a heartbeat for the project, like a scheduler, and that's where the other half of this stack comes into play, the Apache Airflow that I have at the root of the project. And this service will use our Ducklake manager on a scheduled task to continuously extract data from multiple sources and if you look at the Docker Compose in here, we do not let it intimidate you. It's pretty straightforward. We got a scheduler, a web server, worker, and which the service is actually does the work. And to manage the job, as we are using the RabbitMQ, which I have defined up here, and inside my Airflow DAG, which should be here, I am reinitiating my Ducklake manager, and we just point it to our config file, and it will do the rest for us. The key point here is I have created my own version of Airflow, the Apache Airflow base image, that inside this image I have initiated the executor that you can see here. So if you go ahead and write like help inside the image, it will gives you an output. So I'm simply creating my executor and add it to the path inside that image. So my base image of Apache Airflow is custom made. So I'm going to explain this in details in the next video, but the killer feature here is look how we set up the volumes inside our Docker Compose. We mapping our local DAGs folder and our config file directly into the Airflow container. So Airflow is smart. It means you can change your config file on your machine, and you can just hit save. You do not have to restart or rebuild your container. The next time Airflow runs that task, it will automatically picks up the new config and creates your new connections and start pulling from your new data source. So it makes your entire data pipeline dynamic, so you can evolve your whole setup by just editing a simple config file. Okay, enough talk. Let's just run the tags, and I'm going to go ahead and run my Apache Airflow stack, and Airflow init is just migrating the database. That's why it's waiting, and it's ephemeral. It will die after it's done its job. And if I just wait for it to get up and running, we good. The API server is doing a hard job. Okay, there they are. And let me just have this open. This is off right now, but if I go ahead and head over to my web server UI of my Airflow, and check out my DAGs, I have a simple DAG here that is simply reading a fraction of the data from all these three sources and insert them inside this table. And this dashboard here is reading from this specific table. So if I wait for it to run and do the job, okay, and check out my data again. So like serve should be working. I did not need to rerun this at all. I could have just waited. I just needed the terminal. That's why I rerun it. So if I head over to the residence, I should see that this is being updated continuously. So let me just wait for 1 minute and see the update that is happening to our Ducklake, and this dashboard must be updated with each update. So I'm running this DAG once every minute. So every minute the data should be updated. So if I return here, so the data is being updated, right? I'm grouping the regions by the number of residents here. So if I designed it so if the data is at its maximum size, it truncates the table and creates the data again. So if I wait a bit, my data should be updated to 0 rows. At the end of this, by now it has 2 rows, so now it's continuously being updated. That's simple as that. So all this is just to demonstrate with this single project you have the foundation of a huge range of data lake infrastructures while keeping your tech stack lean and efficient. But do not take my word for it. To realize its true power, you need to use it. So clone the repository and start building your own pipelines. And now if you know what this project is capable of, the next video I will show you how to get started. I'm cloning it and running it from scratch, walk you through the key parts of the code, and yeah, that's it. So stay tuned for that, and if this video helps you in any ways, please like and subscribe. So once again, to refresh my data, so this is being updated actively, and happy coding. So